Well, I want to welcome everybody to tonight's Fallbrook Climate Action Team talk. And for those of you who might be new to us, we are a group of just regular citizens like you who are concerned about climate change and have resolved not to go down without a fight. So to that end, we've been putting on talks, first in person at the library for about 10 years, and then since COVID on Zoom. So we have been able to entice some terrific speakers from a distance, like our speaker tonight, Dr. Matthew J. Forrest. He is willing to take your questions live, but you can also type him in the chat and we'll see how that goes. Probably type him in the chat as well as raise your hand, and we'll make sure we can get through the whole talk. I would hate to lose any of it. What else should I bring up? Joy, what am I forgetting that I should be telling people right now? Oh,
Next month.
I think we might want to tell people about next month's meeting, which Tom can tell you about briefly.
All right.
That's about it.
Next month is really great. One of the aspects of climate change is land use. And we're going to have the Fallbrook Land Conservancy talk to us about all the preserves in the greater Fallbrook area that they control, and how the species all interconnect on these preserves around town. So you don't want to miss that at the end of May. Last Tuesday in May. We'll send out emails on that.
That sounds great. And I'm going to discuss a little bit about conserving species as well tonight, particularly a little toad that I happen to be very fond of. So I think you'll like it too once you see it, because it's probably the cutest toad you're ever going to see in your life.
That would take some doing. I don't know.
Okay, well, we'll see.
This is yeah, we are seeing right now Dr. Forrest. He is from Scripps with a degree, his PhD is in oceanography, but not one to be bound to any one thing. He's also got a degree in English, marine biology, and marine sciences, and seems to have a varied very varied interest, portfolio. So he's going to be talking about geothermal energy and its practicality and impracticality tonight. And he's going to be bringing to it like a pretty wide range of perspectives. And turn it over to Dr. Forrest right now. Thank you.
All right, thank you very much. Okay, I'm going to switch this over to share screen and we'll get this rolling. So the title of the talk is Geothermal Energy Benefits and Concerns. And I will make this a full screen so everybody can see it. Can everybody see the slides right now?
Yeah, please. It's both.
All good?
Come on, please.
Perfect.
Yeah.
Okay, so I mean, you guys are much more interested in the benefits of it, so I'm not going to belabor too much on the concerns, but I think it's important that whenever we talk about things that we look at both sides, or all sides if we can. So some of the real benefits of geothermal energy is, it promotes economic growth. It's fairly low maintenance once it's built. It's, in theory, renewable forever. It also can cool, and it can really enhance the stability of the grid. In fact, in Nevada in particular, as we'll see, there's a lot of geothermal coming through. And we in California, because we have a mandate to buy green energy, we actually get quite a bit of geothermal from Nevada as well, despite the fact that California has the largest geothermal plant in the world. It also, as far as the reduced land footprint, that's iffy, but it is environmentally friendly and it is a consistent source of energy, and it doesn't really emit a lot of greenhouse gases, certainly in comparison to burning fossil fuels. Now, some of the concerns, you can see kind of a list here, but the things I'm going to kind of talk about today are surface water pollution, disruption, and actually even depletion of some of the surface water. If you overexploit, and this is important, If you overexploit a geothermal resource, you can dry up particularly the hot springs that are coming up naturally. And that you'll see why that's important later. I'm also going to talk about water pollution due to leakage from geothermal wells into other nearby geothermal wells. And this was a study I did when I was at Scripps with some folks from USGS, United States Geological Surveys, and you'll see the results. It's very interesting. If anyone's ever been to Calistoga, you've probably seen a lot of the hot springs up there. There's even a geyser in Calistoga that comes out literally at 100 degrees Celsius, comes out of the ground. So it's nice for us because we get to use that as an end member, saying, this is what a real geothermal system looks like. The other thing I'm going to talk about a little bit is induced seismicity. And it turns out this is something that we're going to have to really think about if we're going to use what we call enhanced geothermal systems. And the reason for that is the same reason you probably heard about earthquakes happening from fracking. You're injecting liquids and breaking up and cracking the bottom of your well. And that can lead to, as you'll see, some earthquakes, and actually pretty big ones at times. Generally, those are small, though. Okay, so the beginning of this is we talk about where this heat comes from. Well, the Earth has 4 major parts or layers. The inner core of solid iron. It has an outer core of molten rock, which we often call magma. And the magma and mantle are surrounding the outer core. You can see this in the illustration here. Let's see if I can get my laser pointer. There we go. No. And then we also have the crust of solid rock, and you can see how thick that is. So basically, where we have geothermal, we have areas for whatever reason where heat is coming out. And generally speaking, that means there's a fault. Okay, so why do we get heat? Well, we get heat for the same reason the sun gets heat. We have radioactive decay, and it actually generates just as hot or hotter than the surface of the sun. And that heat, as you might imagine, is constantly radiating out from the source and trying to find pathways out. Okay, and then when these deep rock formations are heated to 700 degrees Celsius, I've put in Fahrenheit for us as well, because we only talk about Celsius in science, but I know it's sometimes hard to grasp. Just an easy thing, 0 degrees, you probably are familiar with. 0 degrees Celsius is the freezing point of water. 100 degrees Celsius is the boiling point of water. Our body temperatures are around 37 degrees Celsius. Okay, so the temperatures, as I say, in the mantle range from around 392 degrees Fahrenheit to, when we get deeper, 7,000 degrees plus Fahrenheit. So not a place you probably want to hang out for very long. Uh-oh, why is this stopping here? Oh, there we go. Okay, so the most active geothermal resources are usually found along major tectonic plate boundaries. I'm not going to get too much into plate boundaries and things like that today. If you have any questions about it, we can certainly discuss it. The theory of plate tectonics was really kind of developed in the 60s. So it's a fairly recent thing to science, but it's definitely true. And we have confirmation of it basically daily. We talked a little bit earlier about deep sea hydrothermal vents. Those are generally located along plate boundaries. And we call this the ring of fire because it's so geothermally active. And as I mentioned before, when the magma starts coming to the Earth's surface, it heats the ground and the water that's trapped in the rocks, or it comes through fractures and faults. Okay, so this is just a database of all the hot springs located in North America. And this is an interactive thing, and you can see the website there. Anyone who's a real hot spring aficionado can actually click on any one of these dots and find out information about it. The darker colors, the more red, means they're hotter. And you can see, again, where are we really concentrated? In this area right here. California, along the sides of the Sierra Nevada, along the coast. Nevada is really cooking. That's where I've done quite a bit of research, and Nevada is really cooking. Okay, so as I mentioned before, a lot of the geothermal springs and hydrothermal springs and hot springs and the geysers are located on faults. And that's true everywhere in the Western United States. The only place that's not true is Yellowstone. And that's because Yellowstone is a super volcano. So it's actually a hot spot in the middle of a continent, similar to what created the islands of Hawaii. But this is a very unusual situation. I don't know of any other hotspot in the middle of a continent. Yellowstone is very unique for sure. Okay, so where does the water come from? Well, it comes from rain and snow, precipitation. That seeps into the ground here, as you can see during the recharge. And then that comes down and it becomes the water underneath, which is the aquifer. So when that hits an area where you have a magmatic intrusion, as you see here, when that is influencing it, and again, this is through faults. These are faults here. That means that it can actually heat up and then get ejected, if it's hot enough, right back up that fault. And there's your hot spring, or even your geyser right here. Now, the geothermal wells are generally located right near these faults, but preferably not right on top of a fault, although they really are at the Salton Sea. The Salton Sea geothermal field is located not only on a fault, but the most famous fault in California, the San Andreas Fault, which is actually what created the Salton Sea in the first place. The fact that it's on the fault made it go like this, and that made the indentation that was later filled, as we'll see, quite frankly, by somebody who was doing something illegal, is the reason that the Salton Sea was filled in the first place. There's an old saying in the West, which is, whiskey is for drinking and water is for fighting. So, okay, so when the hot water contacts the rocks and the sediments, this is important as well, it actually alters the geochemistry, and it can increase certain things or it can remove certain things. And you're going to see later on why this is pretty important. One of the things that we've kind of alluded to is lithium. So lithium is incredibly common. It's one of the most common things you're going to find in any hot spring water you ever sample in the United States. So this is a really nice diagram that shows us the various different types of geothermal energy. Over on this side, we have the simplest, which we'll discuss kind of at length here because it's probably the most pertinent to you all, which is a geothermal heat pump. And that's been getting a lot of attention lately. And it turns out that there's a lot of rebates that you can get if you install this. So I think that was an important point to bring up for you all. And here's our hot spring. And you can see, again, this is showing you the faults that are underneath, okay? This is a flash binary power plant, which is the most common type of geothermal power plant. And by flash binary, what it means, well, flash means that they actually take the water under pressure from the ground, open it up, release some of that pressure, which then turns the hot water into steam. And then that steam is used to turn a turbine, which is essentially the way we create energy no matter what we're doing. The only way we can create energy that we are going to put through a line is to turn a turbine with steam somehow. So there are systems that just use direct steam out of the ground. It's that hot. And those are the real serious ones. So you can also see what's called a binary power plant. And the binary power plant is very clever. What it does is it runs hot water that's not hot enough to turn to steam next to another substance, say isobutane, that boils at 11 degrees Fahrenheit. So the hot water actually causes that other fluid to boil, and then that causes the steam to turn the turbine. It's quite clever, actually. And then the final thing here is the enhanced geothermal systems. And these are, the nice thing about them is they are available anywhere in the world, as long as you're willing to drill 4,000 kilometers into the ground. The bad thing about them is they have the same aspects as things like fracking, in that we can actually induce earthquakes from them. But this is a newer technology that's really ramping up now. And there's enough energy there in the Western United States that it would actually exceed the amount of power we're already producing in the entire United States. So the potential is really high. So this might surprise some people, but United States leads the way by far in geothermal. I mean, we're quite a bit ahead of the next one, which is Indonesia. The darker colors mean more of it's being used. And a lot of people think about places like Iceland. Well, Iceland's just not very big and doesn't have that many people. So they don't need, it's very cooking because Iceland actually exists on one of those tectonic plates. If you go to Iceland, you can scuba dive in between two tectonic plates, actually. Yeah, it's pretty amazing. And Mexico has quite a bit. I did my master's work down in Baja California, and I dove scuba dive on shallow hydrothermal vents. And that was quite an experience. Some of these shallow vents, and by shallow, I mean between about 30 feet and 100 feet, because scuba diving past that depth is just not very amenable at all. You have to really do some dangerous stuff. So at one of them, which is, if anybody's ever been down to Ensenada, there's a place called the Bufadora south of Ensenada. And that Bufadora refers to a blowhole. And it's quite a famous spot, but right where the blowhole is at, there's a vent that comes out of the ground at 100 degrees Celsius at 100 feet. And it's producing gas that's about 70% methane. And of course, people want to exploit these things, but they're not very big is the problem. They're pretty small. Plus, quite frankly, we don't really understand them very well. So if we exploit them, we'll probably ruin them for science in some ways. But this is an important point down here. 1 megawatt is 1,000,000 watts, 1,000 kilowatts, enough to power 750 homes at once. So just to give you an idea of scale. Okay, so we kind of alluded to this already. Why do you think this one's green right there? Anybody have a thought of what that is right there?
That mountaintops, what is that?
That is exactly right. That's the Sierra Nevadas right there. And the Sierra Nevadas, except for around Mammoth, they're actually what's called a plutonic intrusion. It's where granite is floating up out of the earth because it's lighter than the other stuff around it. So we don't really have it there, but we have it everywhere else. And like I mentioned before, Nevada is really cooking. So what do we have? The geothermal energy cuts to the earth in three ways: volcanoes, hot springs, and geysers. Now here's another map that I think is kind of pretty. Shows you basically the same thing. These yellow dots are areas, can't read the legend because your picture's over it, but I want to say over 90 degrees Celsius. And then you can also see, which we've been kind of ignoring, Alaska has quite a bit. And then what do we have right here? What do you guys think that is right there? That's that volcano in Hawaii that erupted recently on the big island of Hawaii. What is that, Mauna Kea? Okay, so this is where we currently have identified geothermal resources, and you can see California leading the way, as we always do. Undiscovered resources, again, California is way up there. And then, as I mentioned before, Nevada takes the next big chunk, right? So, you can do stuff besides just gamble in Nevada. You can actually get some geothermal energy too. A fairly similar map, warmer colors, higher favorability. The dots are identified geothermal systems. Boy, you can really, so this would be Clear Lake up here. That's the one that has the geysers. This is the Salton Sea down here. And then look at Nevada again. It's just full of this stuff. Okay, so this is kind of a cool slide right here because it really breaks everything down for you. You have very low temperature stuff. Sometimes hot springs come out of the ground around 30 degrees Celsius. That's not going to do you a lot of good because that's actually cooler than your body temperature in terms of heating up hot water or driving a turbine. But it's great for heating a greenhouse or a single family home or something like that. They actually use this for aquaculture. You can see down here, the geothermal heat pumps would be here. This is for farming and aquaculture, greenhouses. And these would be lower temperature hydrothermal springs that can just be used. In fact, one of the bigger fish hatcheries that's in Mammoth, Hot Creek, is using natural geothermal to help speed up the life cycle of the trout that they raise there. Okay, so then you've got your low temperature. Now, low temperature, they're talking about 90 degrees Celsius, not that low, but relatively speaking, your medium temperature is 90 to 150. These are deeper. You can see we're going deeper typically. Very high temperature. These are found near, as we mentioned before, plate boundaries, hot spots, and very high tectonic activity. They're great for power plants because At sometimes you can actually, as you'll see in a minute, just get direct steam out of the ground to run the turbine. And then these ultra deep ones, supercritical, that's where we're talking about drilling down to 10,000 meters underground. And the temperatures are very high up there. Now, they're difficult to access because you've got to drill really deep, but they're pretty much available anywhere in the world that you're willing to drill really deep. Okay, this is just sort of a generic slide showing you what a geothermal power plant would look like. You've got your production wells. Again, these are cracks that are related to faults under the ground. You've got your hot water coming up. You can even drill into hot granite. They've been talking more and more about using old mines to do geothermal because they're already dug deep into the earth and it's very hot down there. If you went down deep into a mine, you'd be sweating because it's very hot. This is what we call the natural geothermal gradient. Anywhere you go in the world, the deeper you dig, the hotter it's going to get. In some places, it's going to be fast. You're going to get hot really fast if you dig. In other places, you're going to have to dig really deep. But the way these things work is they go through this heat exchanger type thing. As we mentioned, they have to create steam to turn the turbine, which then generates the power. And then the other important part of this is that we try to re-inject the fluids back in. If we do that, in theory, this resource can be infinite. If we don't do that, some of this water that's down here is tens of thousands of years old. We even call it paleo water. It came during the Pleistocene when it rained a lot, and there used to be lakes covering a lot of parts. Anywhere you go in California where you see what there's called playa deposits, those were lakes as recently as a couple hundred years ago, a couple thousand years. You might have heard about Lake Manly refilling in Death Valley. And then there was also, I can't remember the name of the lake, but there was another lake that appeared in Central California, Eastern. Thank you, yes. And that was a lake historically. If you went back and looked at maps from 100 years ago, it was a big lake. It was actually volume-wise bigger than Lake Tahoe because it was such a long lake. It wasn't deep, but it was very long. And the reason that it refilled and became a problem is because they're extracting so much water so fast from that the land is subsiding. And that's why we had this problem once we had all this rain and it filled. You probably saw pictures of it with pistachio trees underwater, right? You know, and so this is also something that's interesting about the Salton Sea. To the north of the Salton Sea, there's a very similar basin that they see historically has been flooded and has had a lake there tens of thousands, hundreds of thousands of years ago. But interestingly enough, when it was flooded, they found a very high correlation with major earthquakes. And the idea behind that is that the water seeps down into the fault and lubricates the fault and causes it to actually go. So this is what you would see if you actually wandered onto a geothermal property, which they probably kick you off really fast. But you know, this is basically kind of what any power plant looks like, right? So as I mentioned before, dry steam, this is the really hot stuff coming out of the ground. This is the earliest geothermal ever exploited in Italy in 1904. This is an actual picture of that. And you can see all that steam coming out. Now, this is releasing water vapor. Water vapor is a greenhouse gas. So there is, you know, that issue going on. However, it's the simplest possible way you could utilize geothermal because the steam can just directly be used to turn the turbine. And as I mentioned earlier, Clear Lake, the geysers in Northern California, this is the largest single source of geothermal power in the world. That's the same amount of electricity that a large nuclear power plant can generate, which is pretty impressive, I think. Okay, so this is how the dry steam works. As you can see, it's very simple. You've got your production well where your hot fluids are coming up and they're actually steam. If anyone's ever seen a geyser go off, think about that going on all the time. And that just directly turns the turbine. Now, again, we got the re-injection. So that's an important component of it because we don't want to lose that fluid. By the way, this will now turn to a fluid when it's re-injected after it's used for that. So, and so these things are very hot. up to 182 degrees Celsius, but there's only two that are utilized in the world. That's the one in California and the one in Italy. As I mentioned earlier, Yellowstone's protected from development because it's a national park, but also I don't know that I want to put a lot of infrastructure on a super volcano. I don't know if anyone's ever seen these scary shows about if the super volcano blows, but you know, it wouldn't be pretty. Let's just put it that way. So again, the steam is directly turning the turbine. That's the big point of the dry steam. Now, flash steam's a little bit different. Flash steam's is hot still, but when it comes out of the ground, it's still in a liquid phase because it's under high pressure. There's a relationship between pressure, volume, and temperature. What they do is then they open that up and they take away some of the pressure, which causes it to flash to steam. And when that happens, then you can turn your turbine, same thing. That fluid then starts to cool off, turns back to water, and then that gets re-injected. Now here, this thing you see as well as brine. And brine's going to become important when we start talking about lithium later. Brine means the really kind of salty, nasty water that comes out of these things that is full of things like lithium. It's also unfortunately full of things like arsenic. So I'm going to discuss that in a little bit. This is the most common type of geothermal plant. And then there's the binary cycle power plant. The binary cycle power plant is very clever because it uses lower temperatures. And what it does is it runs another fluid, like, for example, isobutane, which you can see here boils at 11 degrees. So you could basically breathe on it and make it boil, right? So then that steam from that is used to turn the turbine. And then you recollect that stuff and you just have a closed loop, basically, like that. So you don't use up the isobutane. The production well, as you can see, goes right back down and injected into the ground again. Okay, then we kind of mentioned this enhanced geothermal systems, and you can see these are getting a lot more complicated and a lot more expensive to start in particular because you got to drill really deep. There's some thoughts about using things that have already been drilled, oil wells that have been tapped out, and that's a better way to do it. But you can see what you're doing is you're injecting these fluids down into this ground, which is actually enhancing the permeability. And as you can see later, we'll see later on, that can lead to earthquakes. But this is pretty impressive that the USGS estimates that there's a potential of 500,000 megawatts resources in just the Western United States. That's the same amount of, basically half the same amount of power we already have going in the United States. I think I misstated that earlier, but that's still an impressive amount of power. So now I think this is something that's much more applicable to you all because anyone can use this. And I don't know of any negative aspects of it necessarily. So the idea of the geothermal heat pump is that the ground temperatures stay at a relatively constant temperature. Depending on where you are, it can be 45 to 75 degrees. So that's warmer than the air above it in the winter and cooler than the air in the summer in most places. So what that leads to is you can actually just bury water pipes into the ground and run water through them in a similar way to what we just looked at with the more fancy and elaborate geothermal. But the water that's coming up is going to be more like 70 degrees or 45 degrees. But that's a lot better than starting with water that's 0 degrees that you have to heat up, right? So you can see why this makes it more efficient to then heat it up. These can also be paired to solar. So in that regard, you're not even burning fossil fuels to power these things. So you can see that it reduces energy costs by up to 50%, producing 0 direct emissions that contribute to air pollution and climate change. So again, I've got nothing but positive things to say about geothermal heat pumps, and I think everybody should have one. I think anyone that's building a new construction should seriously think about using geothermal heat pumps. And what you can do is you can just run the water through your floorboards. And so you can actually heat the entire house by just running water through the ground. And it's heat rises, so it's very nice. It's a very pleasant thing. You walk on these tiles and they're very warm under your feet. Okay, so you can see that they can be buried in horizontal trenches below the Earth's surface or deeper in vertical ones, depending on where you're located and what you want to do with them. Of course, the more you're talking about going deeper, the more you're talking about bigger installations are going to cost you a lot more money. So in this area, I think you wouldn't have to go into the ground more than about, 6 to 10 feet to have a nice geothermal gradient. So the nice thing about this is it can actually work in reverse. So it can also heat, but it can also cool your house as well during the summertime. And you can see that they're very efficient. These are some kind of getting into the cost a little bit. So they can start at $800. Now, $800 is going to be a pretty, rudimentary system for sure. 50,000 is more like for something that's powering a large building. We're talking about a lot of heat. They're also eligible for a lot of incentives right now, including I'm going to show you another slide in a minute here. The IRA, the Inflation Reduction Act that Biden passed, they will pay for 30% of your installation directly. And these can be stacked, by the way. In other words, you can get the federal one and you can get the state one, and you can even get a local one potentially. Rebates, things like that. So. Okay, so there's also ways you can do it for a whole neighborhood if you plan ahead. And this is really a nice way to do things because, as you can see here, the network can achieve more than 500% efficiency. So for every unit of energy goes in, you get 5 out. Now, we don't have a lot of things like that in the world, do we? So, I think that this is, like I say, very positive. You can see that in this neighborhood in Whisper Valley, Texas, 400 homes were connected to a geothermal heat pump system. And I think we all know how hot it can get in Texas. So if you had something that was 75 degrees, say, that's a lot more pleasant than 112, right? So you can live with 75, I think. Okay, so this is kind of just for your interest in edification here. I'm going to make this available to you all if any of you are actually interested in doing this. As I mentioned before, you've got the federal stuff from the Inflation Reduction Act, a tax credit where 30% up to some amount there. I can't read it because it's behind your pictures. What does it say, 2,000? And then there's also California has incentives as well and rebates. So you can save up to $5,000 on if you combine these. And then in certain areas, for example, in Sacramento, you can get $3,000 back for this on top of these other incentives, by the way. So I really think, it makes it very well worth it. Like I said before, particularly if you're constructing something right now, you should really think about using one of these. Okay, so let's switch gears a little bit here and talk about that lithium mother lode. This has been in the news quite a bit lately. I don't know if you guys are familiar with it, but there is a lot of lithium in here, and we'll see why. You probably are pretty familiar with the Salton Sea, probably know it better than I do. People my age don't really go to the Salton Sea except for to look at the gross dead fish on the shore. But 50, 60, 70 years ago, all the Hollywood stars went there, and it was a beautiful place where all these birds and wildlife. Now you see a lot of dead tilapia if you go there. And there's also, by the way, what are called mud volcanoes just to the south. And if right here on this map, we'll see in a minute, there's a bunch of geothermal right here that's running. And it's really cooking because this is the San Andreas Fault. We are literally on the San Andreas Fault right here. So this is kind of a controversial story, and depending on who tells it. But my understanding is that the Salton Sink was already there, and that's because of the fault. The fault is moving like this, which then causes the Earth to drop down underneath it. That's called a graben or a half graben in geology. And what happened is somebody up here redirected the Colorado River because they were fighting over water, drinking whiskey and fighting over water, and that ended up flooding the Salton Sea. And the whole thing was illegal, and it should never have happened, but, I guess it was a happy accident of sorts. So, this slide says it was a popular recreational area. It still is really important for migratory birds flying over. However, you can kind of see from this picture, it's not the loveliest place. If you guys ever been there, it smells bad. And there's also some serious issues with the fact that the dust gets airborne and it's full of pesticides and it's dangerous. So people have real respiratory problems around the Salton Sea. Basically, the only people who live there year round now are pretty much insane, and they have these encampments, and it's a kind of a scary place, to be honest with you. So if you go with a group. So here, as I mentioned before, to the south, there's these geothermal brines, which are coming out from underneath the Salton Sea. It's not really necessarily directly related to what's in the Salton Sea, although that now, because of evaporation, is also full of lithium. But these brines are really important because there's a lot of lithium in them. And the idea is that we can extract that lithium by bringing those brines up to the surface, which we're already doing in the geothermal plants. Every geothermal plant is already bringing up brine that's loaded with lithium. There's just another step in there to take the lithium out before you re-inject the rest of it down. But it's a much smaller environmental footprint compared to traditional mining. And there's also, particularly in South America, they use what are called evaporation pools. And those take up a lot of room. So I see I got some chats here. Do I need to take a look at some of these? Oh, meteoric water. Meteoric water, I don't know where that came from, but it just means rain, and it came from the sky. It's falling like a meteor. But yeah, that just refers to fresh water that's falling as precipitation, either rain or snow. Higher favorability. I'm not sure where that came in. Cynthia?
One of your slides, it was pretty early in, so you talked about areas of greater favorability.
Right. So the favorability part would be that there's the steeper geothermal gradient there. So in other words, that you're near a fault, it's hot. The magma is coming up somehow there. It can also happen around volcanoes, as you might imagine, right? So in fact, we think about magma coming out of a volcano, right? So any volcano you go see, you're going to see hot springs on the periphery of the volcano. Let's see, is water steam always necessary? What about using the temperature gradient, say air? Well, we have to get it hot enough to turn a turbine, right? Or we're using that binary process. But it's always water being brought out that starts this thing. As far as using air, I'm not familiar with that at all. And I don't think I don't think you get a lot of bang for your buck from it. Let me put it to you that way. Medicine Lake Highlands in Northern California should be a national monument, not a geothermal plant. Okay. I have not been to Medicine Lake, but I have been to Clear Lake, and it's pretty wrecked because it was also where all the gold mining went. And there's a huge mercury contamination problem there from the gold mining, and mercury also is associated with geothermal. So there's another lovely thing that comes out of the ground. Had a geothermal in Monterey, 10 feet deep. It worked great. Awesome. Also, when I lived in northern Montana, my neighbor had a similar system that worked great too. I don't know how deeply the pipes were buried. See, 10 feet near Monterey. That's great. Thank you for saying that. Okay. Next. Okay, so this is how vaguely, I'm not going to get into too much detail here because quite frankly, I don't know how these things work. And honestly, this is new technology, okay? And there's a lot of people saying we're going to get all the lithium we want out of that. As usual, there's some naysayers out there too. So I usually try to fall in the middle there. I would imagine some of the estimates about the amount there, we're not going to be able to get all of that. But it's going to be a help regardless. So I'm all for it. I also think it's going to bring money to the environment, which is desperately needed. And perhaps, sorry, there's a helicopter going over me. I don't think they're looking for me though. Okay, so what happens here is you can see these are the lithium ions that are coming off, and we can collect those. And then we can just re-inject the rest of the stuff down. So, maybe we don't care as much about iron and calcium, sodium. We just we leave that back in the brine that goes back down. But we're going to pull the lithium off so we can make the batteries and such. Okay, so this is what I was talking about. This is the recent study. They estimated the reservoirs of 2.6 million tons of lithium. Well, we use 200,000 tons annually in the entire world. So that's a substantial amount, 2.6 million tons. And it's also much more green than the traditional ways that we're mining lithium. If you go out to these playa deposits in the desert right now, for example, where they have Burning Man, that's called the Black Rock Playa. That was a paleo lake. There's also a lot of hot springs there, by the way. And you will go see, if you go out there like tomorrow, you're going to see that there's stakes everywhere because people are claiming them as mining spots. And what they want to do is they want to just basically rip up all of those playa deposits and process them. And that's not a very environmentally friendly way to do a thing. And you were talking about land use. That's a lot of land. And there are critters that live there. So, you know, it's not just because it looks desolate doesn't mean there's nothing that lives there. Okay, so this is sort of your pipe dream, if you will, if you'll pardon the pun, of where we could be going with this. And what you see is you've got your geothermal plant, which in our area is already existing. In fact, that's an actual picture of the geothermal plant that's right to the south. I think the Salton Sea would be right up. Oh, there it is, right there. You can see it. So that's how close it is. And this, again, is like basically right along the San Andreas Fault. So what we can do, well, we can have our geothermal heat gradients heating our homes. We can have our geothermal power plant providing energy and for everybody. We can then extract our lithium, and we have our lithium pilot plant that was creating batteries or using the lithium to make batteries. So this is, you know, what we think could happen in the best case scenarios. And we hope it's going to happen for sure, because we do need the lithium at this point in time. It's the reason lithium is so good for batteries. One, it's very light. It's a very light element. The other thing is it loves to give up electrons. It loves to share its electrons because of the chemistry of it. So that's why it's so good for batteries. It's not the only thing. In fact, they're talking about using sodium, and, you know, sodium is everywhere, right? I mean, that's what makes the ocean salty, sodium and chloride. So they could possibly use sodium. All right, so let's get into the concerns a little bit. I mentioned the induced seismicity, but this is where we kind of, so what's happening here, and this is actually what fracking is. A very interesting story related to Scripps is one of my colleagues at Scripps, his father invented fracking, but he actually works with algal biodiesel, and he's trying to clean up the world. Now, his father realized what he had done was probably going to be a big problem. So he sold the company, took the billion or whatever he got from it, and then actually for the rest of his life built sustainable development housing and whole neighborhoods of sustainable development. And he put all that money into funds for sustainable development. So he foresaw the problems that were going to be associated with fracking. Not only are we now exploiting more fossil fuels, but we're also doing things like causing earthquakes. And there's been thousands and thousands of earthquakes in Oklahoma that never happened before because of the fact we're shooting this fluid that, by the way, nobody knows what's in the fluid, the fracking fluid. That's a proprietary secret. But we do know that it tends to melt and fracture the ground underneath. And that actually opens this stuff up. And if you had little pockets that were separated, now it's opened up and you can exploit the rest of the gas or the oil that's in there. Okay, but as I mentioned before, you can also start earthquakes. And normally they're pretty small. You know, here in La Jolla, we often get earthquakes this size related to the Rose Canyon fault, which is the thing that created Mount Soledad, and also the two canyons that are off of La Jolla. It's a pretty substantial fault. More recent work suggests it could have a 7.0 magnitude earthquake. Let's keep in mind that magnitudes, that the Richter scale is on a logarithmic scale. So the difference between 1.0 and a 3.5 is actually thousands of times stronger. And a 7.0 or a 9.0 could be 10,000 times stronger. And here you can see that in Basel, Switzerland, they were doing a pilot project with this deep geothermal. And it triggered a 3.4 magnitude earthquake. And they know that's what caused it. It also caused a big earthquake in South Korea, 5.5, the second largest earthquake in South Korean history. So, you know, this is something we need to be very careful about when we're doing this type of stuff. Oh, there we go. I don't know why it does that. Okay, so this is just a little more, giving you a little more of the nitty gritty about what's happening here. I'm not going to belabor this, but it basically is changing the pore pressure in the rocks. And if there is a fault nearby, that can actually lubricate the fault and cause it to slip, and then boom, you have your earthquake. Okay, so this was one of the papers that I did when I was at Scripps, and this was with some folks from USGS. We went around to 44 different public supply water wells in Napa and Sonoma County, and we found that some of them are being contaminated by the nearby geothermal wells because they weren't drilled very well, and they're leaking into the other ones. In fact, in the town of Calistoga, despite the fact that people go buy Calistoga water and love it, they don't drink the water in Calistoga because everything's been contaminated to a point where it turns out in Calistoga, if you drill down 100 feet underground, you're going to get water coming out damn close to boiling. That is such a steep geothermal gradient there. And there is a geyser in geothermal that shoots out of the ground, just like, you know, you think about Old Faithful. So we found the real concerns here are things like arsenic. Arsenic can cause cancer. There are human source pollutions of arsenic, particularly pesticide. It was used a lot as pesticide. It turns out if you feed a pig arsenic, it grows faster. If you feed a chicken arsenic, it grows faster. So they would mix it in with the feed. I don't think they do that much anymore, but they did. Now, arsenic is one of these things that everybody is afraid of, and it has a long sordid history of being scary. But arsenic is only particularly dangerous to us in its reduced state, meaning when it comes out of the ground, it has not been exposed to oxygen. Once it's exposed to oxygen, it's no longer as bioavailable to us. So if you had water that had arsenic in it, the simplest way you could try to mitigate that is by just bringing it out of the ground, letting it cool off, and get exposed to oxygen. And then the microbes actually start doing their little tricks and cause a lot of the arsenic to precipitate out of the water. So what you'll end up seeing is a little rust stain on the bottom of whatever you've got there. And that rust stain is iron oxyhydroxide. It is rust, but it also sorbs up things like arsenic. So it does us a nice favor in this case. Now, mercury is the opposite. Mercury, you guys have probably played with mercury. I bet you everybody in this thing has played with mercury in some science class, right? Quicksilver. And you know, it didn't kill you. It probably made you stronger. But it turns out that you need to methylate mercury. And this is where when you hear about fish containing high contents of mercury, microbes will methylate the mercury. Then it becomes bioavailable to us and dangerous to us. But mercury in its elemental state is not that dangerous to you. I don't recommend that you break open a thermometer and drink it, but it wouldn't be as bad as if you ate 10,000 pounds of tuna, I think. So. And the reason that, you know, the fish, as an aside, that the larger fish tend to have much more mercury in them is they live longer and they eat a lot of other fish. So it does what we call bioaccumulation. And this is why you see things like swordfish having the highest mercury contents. They're very long-lived, and they eat a lot of other fish. Okay, so as I mentioned, we have arsenic, fluoride. Now, people think about fluoride, and you know, there's some people who are conspiracy theorists about fluoride, and they say, you know, we shouldn't be putting it in the water because, you know, it's going to mind control or whatever they think. Turns out the amount of fluoride we put in the water is typically, it's such a small level of fluoride. It's micrograms of fluoride, whereas coming out of some of these hot springs is milligrams of fluoride. So 1,000 times the concentration. Was there a question there? So fluoride, for example, in your toothpaste helps your teeth. And it does that by killing off the stuff, the bacteria that cause it. In fact, I just read something. They recommend that you leave the toothpaste, basically residue on your teeth when you don't rinse it off. So that's how the fluoride works. But if you have too much fluoride, it starts replacing the calcium in your bones and your teeth. and it's not as strong as the calcium. So people, there's a place I worked in, Mammoth, Arizona, that has naturally very high levels of fluoride in the water, and nobody's got any teeth there. And you know, the bones can get brittle. If anyone's watched specials about the hydrothermal stuff about Yellowstone and how the bison go to the geothermal when they're in the really serious winters. Well, not only are they getting a lot of fluoride, which is destroying their teeth and their bones, but they're also chewing on grass that's loaded with silica, glass. They're chewing on glass. And what it does is it wears their teeth down. But it's a choice you're going to have to make. Do you freeze to death and get buried in the snow, or do you go up to the geothermal and live for a couple more years? We call it a deal with the devil. I got in trouble with one of my advisors at Scripps because I wrote, they're making a deal with the devil, and he didn't like that very much. He didn't think it was very scientific. Okay, so this is some of the analyses that we did for this thing I did with USGS. This is what's called a principal components analysis. What it's showing you is these are the hot springs. This particular one is the geyser right here. These are some of the ones that these triangles here are the ones that are contaminated wells. This is seawater. A lot of the reason why we are actually allowing a lot of the water, the fresh water in the delta of Sacramento to reach the ocean is not to save some little fish. It's because if we don't, saline intrusion is going to occur on every well, and salt water is going to start creeping up the river, and it's going to destroy everything. You can no longer grow crops with salt water. You're going to have to desalinate your water coming out of your river. So the idea that we're only doing this to save some little delta smelt fish, the delta smelt is an indicator species. It's telling us that that area is healthy enough. That's why we're trying to save the delta smelt, not because people really care that much about the fish itself. Okay, so as I mentioned, arsenic can cause cancer, high fluoride. There are actually places where they have these, what are called arsenic clusters, and something like 30 to 40% of the people will have cancer in these environments. And, you know, that's a pretty big deal. When you think about the costs of taking care of people, you're talking about some really important stuff, because these are what we would call externalities, and they're not factored in by economists. And in fact, the free market can never capture an externality. It can only be captured by regulation. So this is a big deal when we start talking about arsenic and fluoride in water. Okay, so on to my favorite. Now tell me that's not the cutest toad you ever saw in your life. Look at that thing. And by the way, it's this big. It's 2 inches. It's the smallest toad that we know of in the world. And it only lives in one place in the entire world, right next to a big geothermal plant. And these hot springs that are coming out, that you can kind of see this pretty water. Here's our little toad hanging out on the side of it. And this is actually, you know, this is just a devised picture, but it is, what it shows you is that they're very reliant on the hot springs. One, because it's the only permanent source of water in the entire area. Two, because over winter they would freeze to death, but they burrow next to the top of the hot spring. And they can actually stay warm enough to survive the winter time. So this was a paper that we just published last year with some, again, folks from USGS. And they did some really interesting work. And they found that, as I mentioned, that these guys like to hibernate. It's not really hibernation, it's called estivating. But they go into what's called torpor. They just basically go into kind of a long sleep where they kind of slow everything down. And they just hang out right at the top of the thing. And if they didn't, they would freeze to death. This particular animal cannot handle being frozen. Some toads and frogs can handle being completely frozen. Then they'll unfreeze and they just walk away, but not this guy. So we found it was a new species. That happened fairly recently. And since that time, there's been a lot of lawsuits, and you'll see why in a second. But it's completely reliant on these springs. And in fact, these are the only places this is found in the entire world. It doesn't exist anywhere outside of this Dixie Valley. And Dixie Valley is a very strange place. It's actually where the Navy SEALs practice. And it's where, after we closed down Miramar to Top Gun moved there, Fallon Naval Air Force Station. So when I've been working in these fields looking for these toads, I've had SEAL Team 6 come by, I'm not kidding, and tell us, you need to get out of here. And they can even turn off your phone. They can turn off your GPS. And when you drive in, there's a sign, a very small sign that says, "Warning, you are entering mock hostile territory, and you will be considered an enemy combatant as long as you are in this valley." Now, they're not going to fire on you, but they certainly track you and they mess around with you for sure. One morning we had some guys come out at 4 o'clock in the morning and buzz our tents at hypersonic speeds, and that was very interesting. So it's a very strange place for sure. I don't know if I recommend you go there unless you're into really strange places. But Dixie Valley itself is the hottest geothermal resource in the Western United States. And there's already exploitation of it by a company named Ormat. In 2012, they applied for and got a permit to increase their wells and their production by a lot. As soon as they did that, everyone who's been working with this toad said, "Oh my goodness, this is probably going to end the species completely." And the reason for that is if you overexploit a geothermal resource, you take the water, and even if you're re-injecting, you always lose some. And that what will happen is it will lower the water table to the point where the hot springs will no longer come out of the ground. If that were to happen, those toads wouldn't make it through the first winter. All of them would die in the first winter. So, and part of the reason why this was successfully blocked for now is because this very same company actually dried out a hot spring that's about 10 miles away from this one by overexploiting it. Now, they claim they didn't, but they did, and everybody in science knows they did. So this has been a big battle, and this is really interesting to me because I love geothermal energy and I want it to happen, but we need to think about the expense of it, right? We need to think about the repercussions of it. So it was listed as an endangered species in 2022, and for now, the expansion is on hold. I'm actually pretty much done here. This was something I did earlier where I found that amphibians that live in hot springs are being saved from this fungus because this fungus dies at 28 degrees Celsius. And if an amphibian lives in a hot spring, it can just warm itself up, which is called behavioral fever, by going up to the top of the hot spring. So this was a fun little paper that we got. And you got to love the title. The title actually refers to Sylvia Plath, the bell jar. And if anyone's familiar with that work, she actually committed suicide. So despite that, the quote, which is that there may be some things a hot bath won't cure, but I don't know many of them. That was the quote that I'm taking here. But she did end up killing herself. So there was some irony in the title. I was actually accused of being flippant about it, but then I told him to read as a literature major, I told him to go read the actual source. And this was the stuff I did for my master's. As I mentioned, I dove on shallow hydrothermal vents. Now, the shallow hydrothermal vents tend to have a separate gas phase. So if you scuba dive on them, they even call it champagne diving in some places because you're diving through bubbles. It's almost like being in a big jacuzzi. It's pretty cool. And I think that's it. So we have one more chat question here, I think. So picture shown does not correspond with what you're talking about. Sorry about that. What was that? I don't remember where that was. David?
Well, it's showing the hot brine used to produce geothermal power at the Salton Sea in California. And you were talking about other things since then.
Right. Well, I tend to ramble. Sorry about that.
Oh, no, I like your topics, but I just didn't see the pictures you were talking about.
This is the one you're talking about here?
I'm looking at the hot brine used to produce geothermal power. And I had a feeling you went through a number of other pictures since then.
Yeah. So what I was mentioning is that, there's already geothermal located there. Here you can see that picture there. And what they're talking about doing essentially is figuring out a system where they can strip, getting pretty dark here, isn't it? Where they can strip the lithium out and then re-inject the rest of it. Is that helpful?
Oh, yeah.
And you can see, yeah, you can see the amounts they're talking about here is basically orders of magnitude higher than what we use every single year. So there's some thought that this could be, a bit of a silver bullet. I personally don't think there's any such thing as a silver bullet in our, fight against climate change, but we need an arsenal, not just one bullet, right?
Yeah.
Okay, any other questions? We got another chat question here. Let's see what we got here. Please mention the Santa Rosa injects its wastewater into the geyser. Okay, well, I didn't even know that, so I'm glad you told us that for sure. Santa Rosa injects its wastewater into the geyser. Well, that's, it doesn't surprise me, unfortunately. These, am I familiar? Yes, I've heard about the bringing the ocean water to the Salton Sea. I don't think that's ever going to happen. That would be coming from the Gulf of California, and I seriously doubt that'll ever happen. And I've read these proposals, and I know everybody has some great ideas. One of the great ideas, the same guy whose father invented fracking, he said, "Why don't we use algae to clean up the Salton Sea?" And the added benefit is then we can take this algae, process it, and turn it into fuel. So, I mean, there's been a lot of people trying over the years. The problem, I think, is it's a very impoverished area. And honestly, who cares about it except for the people who live there? Sad to say, but, it's kind of a sad fact. If this was happening in Beverly Hills, I'm sure it would have been fixed already. Or my tawny town of La Jolla, right? Although we've got our own sets of problems here. Okay, any other questions that I can answer?
Yeah, I keep going back to it. It seems like we've been using steam to make electricity
I
for
agree.
150 years.
You think there'd be better technology, but that's what nuclear does too, so I mean,
Yeah, so I keep thinking there's got to be something anyway. So I suppose that would be more of the engineering side of it, right?
that would definitely be anybody want to chime in there? I mean, seems like some of you guys know quite a bit about that type of stuff. I mean, look, we all, we probably all read about cars that ran on water, and then supposedly GM or Ford bought it out and shut it down. I mean, I think we've all heard about stuff like that, right? Personally, my feelings are, for example, with solar has a lot of the same issues that we're talking about with regard to the geothermal. If you locate huge things of solar panels in the desert, you're destroying everything underneath it. And there's a lot of things like desert tortoises that are being really badly impacted by that. So I believe personally that solar should be on every building. There's a building right next to Scripps and UCSD that was built by Ventnor. Craig Ventnor is the guy who the first person to actually figure out how to do the entire genome, map the entire genome of a person. Guess who he chose to map, by the way? Himself. So anyway, but he built a building there with all the money he made. And it not only is 100% does it take care of itself, but it exports energy and water to the nearby buildings as well. So I really think if we play with the building code, particularly with these geothermal heat pumps, and start giving people good rebates. I don't know why they're taking away the rebates for rooftop solar. I think that's awful. I would imagine out in your neck of the woods, you have a lot of rooftop solar, right?
We do.
Yeah, I think it's terrible. Seawater, salt, and sea. Yeah, the toxic dust. You're right. I mean, for sure. I mean, the big problem with the water at Salton Sea is it's evaporated so much that all that's left there is, first of all, it's saltier than the ocean by a lot. If you went and swam in it, which I don't recommend, you would float just like the Dead Sea. It's an evaporative basin. There's no new water coming in except from agriculture. So, and we're certainly not going to flood it again with the Colorado River. I can guarantee you that. I was actually involved in a project where the Nature Conservancy paid, I think, close to $1 billion to allow the Colorado River to flood all the way back down to the Gulf of California. This happened several years ago. And we flew over it in a plane, like we were mowing the lawn, and we took pictures of the entire thing. And it's pretty dramatic. I mean, it was the first time that's actually flowed in decades. And you should have seen the people reacting to it. It was really spectacular. And by the way, the estuaries of the northern Gulf of California were some of the most productive areas in the entire world. And now they're suffering from a similar fate to the Salton Sea. They're saltier than the Gulf of California itself, and they're loaded with pesticides because of the agriculture that's going on around them. And that would, if you allowed the Colorado River to go its natural course, that could be rectified. But we all know what's going on with the Colorado River, and there ain't no way San Diego is going to let go of our portion of the Colorado River to flood back down there. It's not going to happen. So
Well, we can always drink whiskey.
there you go. That goes back to the old saying. Salton Sea Silver Bullet is supposed to be the CARB scoping plan and is set to mitigate the measures to reduce greenhouse gas emissions. Well, good luck. Again, as I say, I mean, I've studied, these ideas of geoengineering quite a bit. I took a class with a woman named Naomi Oreskes who wrote a book all about how the powers that be are actually lying to the public the same way they lied about the link between cancer and smoking cigarettes. In fact, they hired the same dirty scientists to promote their stuff. So it's an interesting story. I highly recommend, if you guys are familiar with it or not, it's called Merchants of Doubt. And I highly recommend that. There's a book and a movie, so.
Yeah.
But I don't think there's a silver bullet. I think there's a lot of smaller bullets that we can be using. And, I don't like to use this metaphor that much, but we need an arsenal. We need to be attacking this with everything we've got. If we start losing the coral reefs, it's going to have major impacts. And I can tell you right now, regardless of your political leaning and your belief systems, the Pentagon right now is planning the #1 fear in the Pentagon right now for the last decade has been what they call climate refugees. So, for example, Bangladesh is half underwater, and the water supply in Bangladesh is so loaded with arsenic that it's killing people left and right. What's going to happen to those millions of people when they're totally underwater? Where are they going to go? So, the conflicts that are going to arise from that is something that I don't even want to think about. So again, I think, we spent a lot of time dithering on this and debating, whereas in the scientific community, there is no debate about whether humans are causing climate change. There is zero debate. There are papers that were just published that show that 99.9% plus of real climate scientists agree that humans are causing climate change. And they have the data to back it up. It's not that they just, we believe this. So that's the thing about science. It's not a belief system. People ask me, do you believe in climate change? Like, well, that's not a good question. Do I know that climate is changing and that we are causing it? I'm pretty darn sure of that fact, because the reason that we've had ice ages in the past is related to the fact that the Earth's orbit around the sun is not perfect. And there are times for thousands of years where we're further away from the sun. It's sort of like what happens seasonally, but over much longer time periods. And when that happens, you can start forming ice. Once the ice starts forming, then it becomes a runaway thing, because what happens is ice has a perfect albedo, meaning when incoming radiation hits the ice, it goes straight back out. Now, the opposite effect happens too. When you start to melt the ice, what happens? You get the ocean. The ocean is dark colored. It absorbs more heat and it melts the ice faster. These are what are called positive feedbacks. And despite the word positive, they're not necessarily a positive thing, right? If anyone watched that silly movie, The Day After Tomorrow, and there's been a lot of talk lately about the fact that the currents could stop functioning the way they've been functioning, which would then shut off the Gulf Stream. And if that were to happen, in about 20 or 30 years, the northern part of Europe would go into an ice age. So I don't mean to scare people.
We're already scared. That's why we're here.
Well, I appreciate that about you all. I mean, we need more people like you that give a hoot, right? So what do they used to call us? Give a hoot, don't pollute.
I have
So,
a couple of friend who did geothermal in their homes when they built them.
Uh-huh.
One in Idaho and one in British Columbia.
Cool.
And I think it was very, very expensive to put it in.
Right.
But it was just the most wonderful heat. I mean, it was just amazing.
Yeah. So you can see some of these types of things here. You can see that, you can actually use it to, for your greenhouse or whatever. If you have a hot spring in your backyard, If you do, you're on a fault. So keep that in mind. But you know, you can, yeah. I mean, you can use it to heat your house. You can use it for your greenhouse, raise fish.
I imagine that as it becomes more in people's, field of vision, the prices are going to go down because as we have more and more companies engaging in putting in these structures. I know that there's some problems with them. You need to have more property than most people have.
Yes, you need a lot of property, I think.
Right, right.
But you talked about,
That's kind of the beauty of doing these systems. And again, this requires planning ahead of time, right? You know, so during the construction period, if you do something like this, where you basically create a whole neighborhood around a geothermal heat pump, and you can see here, I don't think I really mentioned it, but you don't even have to necessarily go on the ground. You can use wastewater, or you can use a pond that's nearby. Why? Because that pond, in Texas, I don't think ponds freeze, but they might. But even if it froze, there's still water underneath it, right? You know, so I mean, you can actually start using some of that. So it's best to use the geothermal gradient in the ground, but you can use other sources as well. And the idea is basically you're starting at a nice ambient temperature that you can either raise or lower through your HVAC system. So you are using the same type of heating system that you would use, but it's more energy efficient because you're starting with a lower or higher temperature. Does that make sense?
Mm-hmm.
But you're right. I mean, it's people who live near hot springs, sure, but you know, again, you're on a fault. I can guarantee you that. So.
No, they didn't. They had enough property, to be able to do it. So
Yeah, right, right.
I wanted to comment on a couple things that people mentioned as far as whether on the chat, whether you need to boil water to make electricity. So John Livingston mentioned that hydropower doesn't boil water.
That's
It
a good
just
point.
uses the water pressure
That's a great point.
to make electricity.
So the
And-
water spins the turbine. The water through the dam or whatever spins the turbine. That's the difference there.
And also
Still using a turbine.
right, photovoltaic
Right.
makes electricity with no turbine.
Well, true, but if you're going to run it through a normal power plant, you're going to boil the water. You're going to use the
Right, but not directly from the sun if you're just using
then you're converting AC to DC, right?
Yeah.
Or the other way around.
mhm.
So you have to have an inverter to do that, right?
Yes.
No, I've played around with solar, and in fact, I have a camper van, so I have some solar panels and a battery pack that, you know, if I go out into the desert, I can charge this whole big, huge battery pack in 3 or 4 hours, and it could power my computer for 5 days, you know. So solar is fantastic, and I have no issues with solar, except again, these huge solar installations don't make a lot of sense. The other thing we got to think about is when you're transporting energy, you're losing energy as you're transporting it. No matter what you do, you're going to lose energy as you transport it. So, you know, those huge power lines that you see coming through Central California, they're making a heck of a lot of noise. Have you ever noticed that before?
yeah.
So those things are just losing energy. So the further we move power, the more energy we're losing, which is why it makes much more sense to just build it directly onto your roof. And for one thing I don't understand is why every parking facility that's covered isn't covered with solar panels, you know?
Right.
We've gotten to the pretty
part of the
cheap.
permit process.
Well, yeah, exactly. And this needs to be, again, built into the building code. You know, and for a while, people weren't even allowed to use gray water, which is the stupidest thing I've ever heard.
Mhm.
So you couldn't recycle your water coming out of your house, clean it up a little bit, and use it to water your plants. You weren't allowed to do that. And they changed those rules, you know, during the drought. So I have a friend who lives near San Diego State, and he's got you know, the rain barrels connected to his gutters. And any good rain that happens here for more than an hour or so, he has hundreds and hundreds and hundreds of gallons of water. It's free, you know. I mean, so I think there are some solutions if we're just smart about how we do things, and we need to be a little less profligate, you know. I mean, we've lived a pretty, in America, we live a lifestyle that, you know, people always talk about, well, you know, China and India are ramping up their carbon, you know, their CO2 and building blah, blah, blah. Well, they still don't use nearly as much per capita as we use, not even close. We are by far the biggest per capita users of energy in the world in the United States.
Very spoiled.
We are for sure. And we're fortunate, obviously. And especially in California, because we have so many lovely resources around us.
Exactly.
Well, I'll look into this carb scoping plan a little more. I'm not particularly Mike is talking about this and carb scoping plan. I'm not particularly familiar with that. I am sure that people of Scripps are already involved in that. So I have no doubt about that. I know a lot of climate scientists, and to be honest with you, I talked to Michael Mann, who's a very famous climate scientist. I know him fairly well, and he's scared. He has children, and he told me, he said, you know, Matt, I'm terrified of the future. I have children, you know.
Right. Well, CARB is just the California Air Resources Board. And
Okay.
so they've developed a plan to get us to carbon neutral
Okay.
with beginning in 2030, or we have a certain number of goals that we have to reach by 2030. And they have the plan that would get us there.
Nice.
And
it's not sequestering carbon, because most people don't believe that's going to work, by the way. Sequestering.
No, they're not talking about that. It mostly talks about reducing
What we need to do.
reducing car traffic.
You people probably do know about this because you're so involved in this type of stuff, but certain days during the middle of the day, California produces more than 100% of its energy from renewable resources. And we're up to, I think, 30 or 40% already from renewable resources, which is pretty darn good. Can we do better?
Yes.
Absolutely. But, you know, we have to have the motivation. You know, as soon as somebody says, you know, if you know, somebody came in and became governor of California and said, I don't believe in climate change, they're going to cut all this stuff immediately. You know that, right? So, you know, and this is where it's on us to behave better as well, right? So
There's a new question here. Do you know how the efficiency compares to a geothermal system of a mini split heat AC system?
I've seen those. You mean the kind of the European style ones that they have? Yeah, I don't know.
Harriet, maybe you should ask that.
What's that?
Harriet is the one that asked the question, maybe.
Okay. Yeah,
Harriet.
I'm familiar with those. You know, you're talking about those small systems that they have that Europe has a lot of that.
Yeah, I have a little system. I used to have a geothermal system when I lived near Monterey, and it really cut my heat bills by a lot. But I have to say, my current house had one of those old style square air conditioners that went when you turned it on.
Terribly inefficient.
Yeah, and I replaced it with a mini split, and the electric bills are really, really low. That is, it does both heating and air conditioning, and and I mean, of course, it didn't cost anything. I mean, it cost whatever to install, but it didn't cost a fraction of what it would have cost to bury the pipes for a geothermal.
Do you remember what that cost you near Monterey? And by the way, I lived in that area for quite a while because I went to Moss Landing Marine Labs, which you're probably familiar with.
Yeah, it was many, many years ago. So it wouldn't have even been comparable.
Right.
So,
but, you know, as I mentioned, you know, I mean, this is why I kind of wanted to bring this up, because there's so many incentives regarding this. And by the way, these are going to go away, you know, so, you know, 2024 is I think the best time to do this in terms of the incentives that are going to be available. And I don't know how much of this money is permanent, you know, from the Inflation Reduction Act. I mean, if Trump becomes president, I'm 100% sure he'll try to cut as much of this as possible because, you know, he thinks that climate change is a hoax invented by China, from what I understand. So I don't know what China is, but I will take his word that that's what he believes. You know, I assume he means China. And again, I don't really want to get political here, but, you know, I mean, it's not debatable that the Republican Party has not been interested in dealing with climate change. Most people in the Republican Party. Now that story about, you know, that I told you about the Merchants of Doubt, I think they actually interview an ex-congressman who was a hardcore conservative congressman. And he went with the scientists to Antarctica, and he was a super skeptic. He did not believe in global warming. It's nonsense. Humans are not causing it. he came back from Antarctica and hanging out with these scientists and became basically 100% advocate for the climate and got fired immediately from the Republican Party. So,
Yeah, they probably haven't found his body yet.
no, he's still alive, but he's no longer an elected official. Let me put it to you this way. So, he should probably go to another district and he might have a chance, right? You know, so
Maybe.
yeah.
Well,
Anyway, I didn't really want to bring politics into it, but I mean, it's not really debatable. And you know, the Koch brothers have been the real enemies of us trying to fix climate change. They've been injecting millions and millions and millions of dollars of misinformation. ExxonMobil knew in 1980, their scientists told them with no doubt that if we continue down this pathway, we are going to cause climate change. Their scientists told them that. They fired the scientists, hired people who were yes men, and suppressed that research. And we've just gotten, and in fact, this is why California is about to sue the crap out of big oil. It's going to make that big tobacco settlement look like a chump change when this goes through. It's going to be to the tunes of hundreds of billions of dollars. And hopefully all that money will get funneled into positive things. And it won't put a dent in the profits that ExxonMobil is making. I can tell you that right now.
Right. This has been utterly fascinating, and I thank you
Yes.
very much for taking the trouble
Yeah,
and
you guys are wonderful.
under difficult times for you too.
Yeah, this is probably true, by the way, this last comment that they require hiring a certified contractor. And that source that I have down at the bottom there, which again, I'll try to convert this into a PDF and send it over to you guys so you can do whatever you like with it and you can laugh at it or
Yeah.
use it.
Thank you.
And then, you know, you can click on that. And I know there's even a zip code finder in that. Now, that group, I try to do some research into them. They're not government official, you know, so I don't know enough about them. They're probably getting kickbacks from some of the contractors, right? You know, we all know how this stuff works, right? You know, so, but you're right about that you would have to hire a licensed contractor to do it if you wanted the rebates.
Yeah.
Of course, if you don't hire a licensed contractor, you probably get it a lot cheaper. So, you know, you might not need the rebates, right? You know. Okay, well, thank you guys very much. Is there any other questions that I probably can answer?
I don't think so.
No, you covered a lot.
Sorry if it was too much. You know,
Well,
I had about 20 more slides that I took out. So.
Maybe you'll have to come back. Pick another subject and come back.
I'm pretty verbose, as you can tell.
Well, that was
obviously
great.
I'd love to. I mean, I'm not a huge expert on the rest of this stuff. I mean, if you want to talk about amphibians and diseases, I would be love to give you that.
For people who came in a little late and didn't get the first part of the talk, this will be on a video that you can upload on YouTube in a week or so, probably.
What's probably going to happen with this PowerPoint is because I didn't shrink the pictures down, which, you know, I wanted them to look good. So it's going to probably be like many megabytes. And it's probably going to be pretty difficult to send except for, you know, through some kind of a Dropbox or something like that. But I can do my best to pare it down and make it smaller. And I can also pull out like this slide right here with the incentive stuff on it. I mean,
Yeah, up for us if you would, and then we'll have the recording of the others, of course.
awesome. That's great.
It's super.
Well, thank you guys so much. And, you know,
Okay.
get on to Scripps sometime. You know, there's a lot of tours you can do at Scripps. Have you guys ever done a real scope tour at Scripps?
No,
I hear
I've heard about it.
No,
Yeah,
You
so why
really-
don't you contact the Scope folks if you guys are up for it and come down. I mean, I could even take you on a tour of Scripps or on the pier or, you know, or a beach geology tour. We do that too. So it's, you know, primarily for kids, you know, because it's about underprivileged kids and trying to encourage them to get into STEM careers. But we work with everybody. So, I mean, you guys organize this through Scope. So,
Okay.
good idea.
All
all
right.
right. Well,
Thank you
guys
very much.
so much. And, is that a Lakers jersey I see behind you there, sir?
Magic Johnson, it's got a signature on it.
Nice. Well, unfortunately, the Lakers. I'm a Clippers fan because, you know, I still remember when the Clippers were in San Diego, you know, so it's,
Lakers have gone home for the year.
yeah, they're fishing now. Clippers are probably going to join them soon, and our Padres aren't doing so great either right now. So I don't know if they're winning right now. Anybody know any updates on the Padres? They need to win a game here. So
Not a thing.
Season's young.
I'll check later. Okay,
Baseball season's young.
what's that?
Baseball season is young.
Yeah, you're absolutely right. I know. My friend told me, he said, let's talk after July 4th. Okay, I have 2 more chat things here. Let me just take care of that. And then I think, okay, thank you so much. Cousins involved in geothermal consulting. Awesome. I bet he knows a lot more about this than I do. Scope invite would be wonderful. Okay, I love that. Thank you, Nancy. And yeah, I mean, please do, you're welcome to show it to him. He can tell me I'm full of it. I've heard it before. And I was, by the way, a docent at the Monterey Bay Aquarium for a little while, and I really enjoyed that. And it's I feel like as a scientist, we need to do stuff like this. We need to be doing outreach. We need to talk to the public, because when we sit and talk to each other, it doesn't do much, right? So,
Okay.
Well,
all right.
thank you for sharing.
Okay,
Thank you
take
very
care.
much.
Thank you so much for inviting me. And you guys are a great group, and I really appreciate what you're doing too, because we need more people like you guys that have a passion for trying to save the world, because we need help, man.
We'll do our
Sure.
part. Thank you for doing yours.
Thank you. Take care, you guys.